Welcome student, welcome to my channel. Today I am going to discuss some important question from coordination chemistry from inorganic side. Okay, now the first question is the hybridization involved in CO C2O4 CO C2O4 whole 3 minus. So in this complex cobalt is in plus 3 oxidation state because C2O4 2 minus is a charge 2, so that's why if we see that X, or we can say it is bivalent. Okay, it is bivalent. So in this case the coordination number of cobalt is 6. Okay, coordination number of cobalt is 6. And the hybridization in this case is sp3d2, that is octahedral. If we draw the structure of this compound, then we can see here oxalate. The structure of oxalate is C double bond O. This is C double bond O, O minus, and this is O minus. This is oxalate. So first of all, we have to bond with all these O. Okay. Then from this side, C double bond O, and like this. Okay, in this case, so the coordination number will be 6. That is hybridization is sp3d2 structure. Okay. Okay. In next, so the answer will be sp3d2. That is correct answer will be option A. A will be the right answer. The next question, which is diamagnetic among the following? So first of all, we have to determine the oxidation state of each compound or each complex. Then we have to find out the number of unpaired electron. So for COF6 3 minus, here cobalt is in plus 3 oxidation state. We can easily determine that X minus 6 is equal to minus 3. So X equal to plus 6. Sorry, plus 3. That's why oxidation state is 3. Cobalt 3. And cobalt 3, this is 3d6 configuration. So F is behave in this case as a weak field ligand. WFL, weak field ligand. So filling of electron take place in octahedral complex D2G, and this is EG. So 6 electrons are filled like this: 1, 2, 3, 4, 5, and 6, because F is weak field ligand. So number of unpaired electron N is equal to 4, and in this case we can see that it is paramagnetic. It is not a diamagnetic complex. Okay. Similarly, in case of NiCN4 2 minus, in NiCN whole 4 2 minus, Ni is in plus 2 oxidation state. Ni is in plus 2 oxidation state. That is 3d 8 electron. But cyanide, due to the presence of cyanide, that is which is strong field ligand, filling of electron, pair of electron take place. So pair of electron take place, that is number of unpaired electron N is equal to 0. 0 will be take place. Okay. So that's why it is diamagnetic complex. So in this case, correct answer will be option B. In case of NiCl4 2 minus, nickel is in also plus 2 oxidation state, but Cl is weak field ligand, so pair of electron does not take place. FeCN6 3 minus, Fe is in plus 3 oxidation state. Fe is in plus 3 oxidation state. So Fe is in plus 3 oxidation state. That's why its number of unpaired electron is 3d5. So here also pair of electron take place, but due to the 5 electron, one unpaired electron is present. That's why it is paramagnetic, and it is not diamagnetic. So the correct answer will be NiCN4 2 minus. Okay. Next, the hybridization involved in is COC2O4 3 minus. Same questions are repeated here. So this is also sp3d2, and this is NiCN4 2 minus. Okay. Next, diamagnetic nature. The following complex which is diamagnetic in nature. Similarly, NiCN4 will be diamagnetic in nature, but in this complex all are paramagnetic. Now, if magnetic moment of MnBr4 2 minus is 5.9 bm, predict the number of the electrons. So how to find the number of electrons? So first of all, we have to calculate MnBr4 2 minus, that is the number of oxidation state is in +2, m in +2, and it is 3d5. So 3d5 and its magnetic moment 5.9. So number of electron must be n is equal to 5. Number of unpaired will be 5. The formula of the magnetic moment SO, spin only magnetic moment, is equal to under root n plus n into n plus 2 bm. So if we put the value 5.9, then we can easily calculate the n, and approximately if we put n is equal to 5, then 5 plus 2, 7 under root 35, almost equal to 5.9. That means unpaired electron must be n is equal to 5 in this case. So the correct answer will be option D. The next question, the correct structure of FeCO5. So correct structure of FeCO5 will be TBP, trigonal bipyramidal. Here Fe, 3 CO are in equatorial position. 3 CO are in equatorial position and 2 CO are in axial position. So the structure is TBP, trigonal bipyramidal. The correct answer will be option D. Okay. Next, the complex chloro-diaqua triamine cobalt 3 chloride can be represented as. So this is the question from IUPAC nomenclature. So chloro-diaqua, that means there must be a presence of one chlorine, diaqua, that means 2 water molecule, aqua, triamine, that means 4 triamine, that means 3 ammonia molecules and 1 cobalt, which is in +3 oxygen state. So according to the correct answer will be, and there must be a chloride outside the third bracket. So if we see the option A, which is the correct answer, chloro diaqua triamine cobalt 3 chloride can be represented like this. Chloro, that means 1 chlorine, diaqua, there is 2 water, 2 H2O, 3 ammonia, 1 chlorine, and outside the third bracket there is a chlorine, that means chloride. And if we determine the oxidation state in this case, so the oxidation state of cobalt will be X minus 1 plus 0 for ammonia plus 0 for water is equal to minus 2. So X equal to +3. So the correct answer will be option A. Now, which one of the following will show paramagnetism corresponding to 2 unpaired electrons? 2 unpaired electrons. Here, if we see that the oxidation state of Fe is +3, and NiCl4 oxidation state is +2, and Fe3 minus Fe is in +3, and NiCl4 2 minus Ni is +2. In APF6 3d5, NiCl4 2 minus 3d8, Fe3 minus 3d5, and NiCl4 2 minus also 3d8. In this case, pair of electron take place, so n is equal to 0, no unpaired electron. Similarly, in this case also pairing of electron take place due to the presence of strong field cyanide ligand. That's why there is 1 unpaired electron. There is 1 unpaired electron because in this case 1, 2, 3, 4, 5 pairing of electron take place like this. So there must be 1 unpaired electron in this case. NiCl4 2 minus N will be 2 because no pairing of electron take place. Here also no pairing of electron take place, and all electrons are unpaired because F is weak field ligand. That's why pairing of electron take place like this, 5 in the APF6 minus complex. So N is equal to 2 in this case. Which of the following show paramagnetism corresponding to 2 unpaired electron? The correct answer will be option B. Because in option B, if we put magnetic moment formula like 2 plus 2 plus 2 bm, in this case we can determine the magnetic moment corresponding to N is equal to 2 value. Okay, next, how many unpaired electrons are there in a strong field iron 2 octahedral complex? Unpaired in strong field iron 2, so Fe2 plus strong field, that means if we consider a ligand like Cn minus strong field ligand, so 3d6 all are paired up due to presence of strong field ligand. So filling of electron take place like this: 1 2 3 4 5 6. So n will be 0, no unpaired electron. That is, how many unpaired electrons are there in a strong field iron 2 octahedral complex? Will be 0, no unpaired electron. The coordination complex copper H2O6 plus has one unpaired electron. Which of the following statements are true? So Cu H2O6 plus, here copper is in plus 2 oxidation state. That means 3d9 configuration. Which of the following statements are true? The complex is octahedral. Yes, the complex is octahedral because there are 6 water molecules and its hybridization is sp3d2. So it is octahedral complex. The complex is an outer orbital complex. The complex is d2sp3 hybridized and the complex is diamagnetic. So complex is diamagnetic. It is not correct. It is not correct because 9 electrons can never be paired up. So there must be one unpaired electron. That means it is paramagnetic. That means it is paramagnetic. So option 4 is wrong. The complex is an outer orbital complex. If the complex is an outer orbital complex, then complex is d2sp3 hybridized. d2sp3 hybridized. It is not possible because all the d are filled up. So to form an octahedral complex, outer d orbital must be used in case of copper H2O6. So the complex is d2sp3 hybridized is not the correct because it is outer orbital complex. So outer orbital complex hybridization is sp3d2. The correct answer will be the complex is octahedral and the complex is an outer orbital complex. Statements are true. More than one correct answer. Okay. Next. Consider the complex MnH2O6 plus with 5 unpaired electron, which response includes all the following statements that are true and no false statements. So if we consider that MnH2O whole 6 2 plus, where Mn is in plus 2 oxidation state and this is 3d5. This is 3d5 electron configuration. So in this case, which response includes all the following statements that are true and no false statements. So we have to find out number of unpaired electron. So n will be 5, number of unpaired electron 5. That means it is paramagnetic. That means it is paramagnetic. So it is diamagnetic. The first statement is wrong. It is a low spin complex. No, it is not a low spin complex. It is high spin complex because the filling of electron take place like this: 1 2 3 4 5. So it is high spin complex. It is high spin complex. So it is a low spin complex. It is wrong. The metal ion is a d5 ion. Yes, it is correct. Metal ion is d5 configuration. The ligands are weak field ligands. The ligands are weak field ligands. Yes, what are here behave as a weak field ligands, and it is octahedral. Yes, it is correct answer. So according to this, the right answer will be it is octahedral. This is the wrong. It is the correct statement. This is octahedral. It is diamagnetic. It is wrong statement. It is a low spin complex. It is also wrong. And this is the correct. The ligands are weak field ligands. Yes, it is correct. So 3, 4, and 5. The correct answer will be option B. 3, 4, and 5. Correct answer will be option 5. Sorry, option B. Correct answer will be option B. So thank you for watching the video. If you like the videos, please subscribe the channel, share with your friends, and stay tuned for the next upcoming videos. Thank you.